Hello students, we'll discuss about hybridization in carbon atom. So as we have seen, carbon is a 6 electron atom. So the two of them are occupied in one s orbital, two are occupied in 2s orbital, and the remaining two are orbital in px and py orbital. And what is special about carbon is that the 2s and 2p orbitals, the energy separation is very small. So the wave function for s orbital and wave function for the p orbital will mix up to give a hybrid energy states. So these admixture will happen in an amount parameterized by lambda, where lambda will quantify how much the p orbital or the p wave function is mixing up with the s wave function. So that means you could have one p orbital to be mixing up with s orbital, or two p orbitals being mixing with s orbital giving 3 hybrid orbital, or you could have all the 3 p orbitals mixing up with the s orbital giving 4 hybrid orbitals. So this is how it happens. So 2s, which was thought to be the lowest one, instead of filling it up using the electrons, now what happens? Now there is equal probability for all the 4 states to be filled up. So the electrons will be filled up initially with the up spin, that is either of the spin, and then only if anything more electron is available, that will be given to s orbital. Okay, so here s orbital was initially filled up only because it was having lesser energy than the p orbital. But what is happening is that due to the mixing up, these 4 states have equal probability to have an electron. So they will fill up individually, or they will be half filled first, then only it will be filled with the opposite spin electron. So that is how a hybridization is happening in a carbon atom. So as we mentioned, 2s and all the 2p orbital can mix up, and hence giving 1, 2, 3, 4 atomic orbitals, and they are called sp3, where 3 denotes all the p orbitals are mixed up to form hybrid orbitals. While in some cases 1 s orbital and only 2 p orbitals are mixed up. So 1, 2, 3 hybrid atomic orbitals are obtained, and 1 p orbital will remain pure, that is unmixed, giving rise to sp2 hybrid orbitals. And another case is where you have mixing up of only 1 p orbital with the s orbital, so giving 1, 2 atomic orbitals, leaving 2 pure p orbitals unmixed. Okay, so you have 2 sp orbitals, hybrid orbitals, having each one having 1 electron each. So all this will be parameterized using the parameter lambda. So now let us see the different structures possible for sp3, sp2 and sp hybridization. For sp3 hybridization, the 3 bonds or the 4 bonds are arranged in order to form a regular tetrahedron. Okay, and in sp2 orbital, you have the sp2 orbitals are aligned in a planar way, that is like a leaf of fan. You can see they are arranged at an angle 120 degree between them. And while in the case of sp orbital, that will form a single line, and perpendicular to this you will have the p orbitals, the unmixed p orbitals. Okay, so that is for sp orbital. You can see sp orbital is lying in a line, and the 2 pure p orbitals are perpendicular to the hybrid orbitals. So example, so as we mentioned, the shape of sp3 hybridized atom will be, or compound will be tetrahedron, and sp2 hybridization is involved. Those will have trigonal, or what you say, planar kind of thing, with a bond angle 120 degree, while sp hybridization will give a linear structure to the material, giving 180 degree is the bond angle between them. So the examples are also given here. So you can see that acetylene is the example for sp hybridization, and ethylene, which is C2H4, is the example for sp2 hybridization, and methane is the example for sp3 hybridization. So these three examples has to be studied by you to know the different kind of hybridization. So the value of parameter lambda is also to be noted. For sp, lambda is equal to 1, and for sp2 it is square root of 2, which means 2 of the p orbitals are mixed up, while sp3 it will be square root of 3. Okay, so in general most of the bond angles for carbon in any of its organic molecule have these values. That means it would be in 109 degree, or it could be in 120 degree, not minute, 120 degree, and it could be in 180 degree. So in all the compounds of carbon you would find only these three bond angle. That was the conventional thinking. And let us see what is this, what is the material you are saying? Yeah, is this diamond. Okay, and what about this one? Yes, it is graphite, which is the lead which in your pencil. So can you compare a diamond and a graphite? Yeah, diamond is very precious, while graphite doesn't have that much value, isn't it? And what about the strength? The diamond is very harder, while the graphite, as you can see, pencil lead will easily get broken, so it doesn't have that much strength. And similarly, the thermal conductivity is very high for diamond, while it is very poor for graphite. But it is very astonishing to see that it is the same element which leads to diamond as well as graphite. So what is the speciality? It is the carbon alone is present in diamond as well as in graphite. But what makes it to be in different property if it is made up of a single element, the same element carbon? So that is what matters. So in diamond the structure is that of a tetrahedron, which means the atoms are arranged with sp3 hybridization, while in graphite it is having a sp2 hybridization. So they will form planes. So each layer is called graphene. Okay, so that gives a different property for diamond and the graphite. So now you can see what is the relevance of hybridization in the structure of a material. So it can make it a precious one or a very common one only because of the change in hybridization involved. Okay, so that is called allotropes of carbon. Diamond and graphite is called allotropes of carbon. And what do you mean by allotrope? Allotrope means it is different forms of the same element in the same phase. So carbon തന്നെയാണ് ഇവിടെ ഡയമണ്ട് ആയിട്ടും ഉള്ളത്, കാർബൺ തന്നെയാണ് ഗ്രാഫൈറ്റും ആയിട്ടുള്ളത്. Only thing is that it is of different forms. So the different forms of the same element in same phase, it is called allotrope. Same phase means here diamond and graphite is in solid phase. So if it is in same phase but with different structure and it is made up of same element, then it is called allotrope. So for carbon. In this particular case, carbon is the element which is present in diamond and graphite. So now let us define allotrope. So allotrope is a different structural modification of an element. So that means atoms are bonded in different manner. While polymorphism is the general term that is used. പക്ഷേ allotropin എന്താണ് വ്യത്യാസമുള്ളത്? For allotropes, it is a different forms of the same element, but it must be having same phase. Then only it is called allotrope. Now let us see what are the allotropes of carbon that we have mentioned just now. Diamond and graphite. Let us have a comparison between diamond and graphite. So in diamond, as we mentioned, it is having sp3 hybridization bonds, while in graphite it is having sp2 hybridized bonds. So what do you mean by sp3? It will form a 3D structure, tetrahedron. So each carbon atom will be bonding to the 4 nearest neighbors because 4 hybrid orbitals are available. So it will be bonding with 4 nearest atoms, carbon atoms. While in sp2 it is a planar one. So you can see each carbon atom, and also it is 3 hybrid orbitals are involved. So carbon atom will be bonding with 3 nearest neighbor carbon atoms, and it will form a sheet because planar ആണ്, trigonal means plane ആയിട്ടാണ്. So hexagonal sheet ആയിരിക്കും form ചെയ്യുന്നത്, and they will be, each hexagonal sheet will be held together by not any bond but by a force, which is van der Waals force. Okay, so that will lead to, so this structural difference will lead to a different property for the graphite. What are its property we have mentioned? Yeah, it is very soft, it is very black in color, flaky, and it is just a moderate electrical conductor, and it has external lattice, and they have layered structure. While if you compare that of sp3 hybridization in diamond, you can see that it is extremely hard material, it is transparent and very poor electrical conductivity but excellent thermal conductivity. Okay, so just a difference in arrangement of carbon will cause a very extremum of conditions in diamond and graphite. Okay, so that will give a layered structure and a 3D structure for the diamond. So people thought that all the atoms, all the compounds of carbon would have all these 3 conventional bond or conventional structure along. Which are they? They are it could be 180 degree, it could be 120 degree or 109 degree 25 minutes. So these were the bond angles that were expected. But later on, new carbon structures were found, or new compounds were found which has bond angle different from the conventional material. So which are they? They are Cubane. Cubane is C8H8 and it has a cubical structure, which means the bond angle made will be 90 degree. So that was the first case that was noticed or discovered which has a bond angle other than the conventional angle. Which are the conventional angle? Conventionally it was believed that either 180 degree or 120 degree or 109 degree are the expected one. 109.5 degree, that means 109 degree 20 minutes are the expected one. And the other candidate was dodecahedrane. So dodecahedrane means, dodeca means 20 carbon. So it has a hedron structure which means you can say 1 2 3 4 5. So 5 sided faces are there, which forms a closed structure like this, and the angle which was observed lies between 108 and 110 degree, which is against which is again different from the conventional angle. So these new structures reveal that other possible bond formation is also happening in carbon, and that was only recently discovered. Okay, and another major achievement was the cluster formed by carbon. Some scientists allowed a laser beam to incident on a target metal disk, and a helium gas is passed through over the metal disk. So what happened is that due to the incidence of laser beam, some of the atom, which is for example graphite disk, some of the carbon atom got evaporated, and those atoms are carried away by the helium, which is an inert gas, and on passing through a very small opening, and once it goes out from that opening, it gets expanded. So expansion will cause the cooling of the gas. So once cool down, what happens? You would have observed when you boil water, vapor will come up, isn't it? And if you close it with a lid, what you can see? The lid is a cooler substrate than this particular region. So what will happen? The water will condense. Water vapor will condense on the lid. So that is why you are seeing water drops on the inside of the lid, isn't it? So similar condensation will happen. So what will happen? The carbon atom will condense to form cluster. So these cluster beams are then studied using mass spectrometer, where you will be checking how much cluster has been formed. So the mass of the carbon or the cluster will give us an idea how many number of carbon atoms are involved in a cluster. Clear? So that is why a mass spectrometer is used. So the people have conducted this experiment. So what is done? A high intensity laser beam is incident on a carbon substrate, causing the evaporation of carbon atom from the surface. Atoms are then swept away by the burst of helium, which is an inert gas, and it is passed through an orifice into vacuum. So no reaction will happen, only the cooling down of the gas will happen because it is vacuum. No reactions or no compounds will be formed, only the clustering of carbon atoms will happen. So the expansion will leads to cooling and formation of carbon clusters, and these are actually neutral item like clusters ആണ്, and they will be photoionized. So they will be given a charge using UV laser, and hence it can be analyzed using mass spectrometer, where we will be measuring mass versus charge. So what is the experimental observation is that it showed higher cluster formation for a mass containing 60 carbon atom. So it shows that more number of cluster is formed for the case where 60 atoms are clustered together. Okay, while the others have shown very less probability of getting in the cluster formation. Okay, so people have thought that the 60 carbon atom formation in a cluster is more dominant form of cluster formation. So a very large mass peak at 60 indicate that the cluster size 60, which means a cluster consisting of 60 carbon atom is more possible to form. Okay, so and hence some of the calculation by molecular orbital theory has also proposed that if a molecule consists of odd number of atoms, then it would be a chain, linear structure ആയിരിക്കും. But if it consists of even number of atoms in a cluster, it would have a closed structure. So it was concluded that since the most prominent formation is happening in 60 carbon cluster, and seconded by the molecular orbital theory, the structure proposed for carbon-60 is that of a closed structure. So the people concluded that this particular cluster will have a closed structure. Okay, so that is how the discovery of carbon-60 happened, and this was actually discovered in astronomy rather. So people has found optical extinction effect, which means the light is getting extincted in the interstellar medium, okay, due to the scattering from the small particles of graphite. Scientists have found that there is a extinction. Extinction means the intensity is reduced due to the scattering from small particles of what? Small particles of graphite present in the interstellar medium. So that was noticed by some astronomers or space physicists. So people thought of simulating the same atmosphere in the lab. So they simulated the graphite dust in the lab, and what they observed is that the spectral line or the absorption line for graphite, as mentioned by the astronomers, have been noticed in lab as well. But together with that, the people also got 4 other absorption bands which are happening in the infrared range. Okay, so they were curious to know why these 4 extra peaks are coming up. So at the same time, theoretical chemists have pointed out that carbon-60 would have an absorption at the infrared range. Okay, so when they checked with the lab experiment, they found that these 4 IR absorption bands are the same which was mentioned by the theoretical chemists. So they confirmed that in the graphite dust there is a presence of graphite as well as carbon-60 clusters. So that was the first evidence or the first thought towards carbon-60. And again, as we mentioned, mass spectroscopy was also conducted, and it was Kroto who proposed that there are long linear chain of carbon molecule present in outer space between red giants, and there is a possibility of carbon present in the outer space, and that is causing the infrared or the UV absorption line. So Richard Smalley was called by Kroto to simulate and to do an experiment on the same. So the experiment we have just mentioned was done by Richard Smalley using graphitic disc, and then actually he got Nobel Prize for discovery of carbon-60. Okay. So then the question again remains, what is the structure of carbon-60? So this was the earlier experiment. As we mentioned, the laser pulse was incident on a graphitic disc, and a high pressure helium was flown over the disc. So the atoms were evaporated, which was evaporated was carried, and then it is passed through a orifice where it expanded, and on cooling off it formed cluster, and on evaluating it was found that this C60 was the most dominant form of cluster that has been formed. So for this he got the Nobel Prize. So here you can see the highest peak is shown by carbon-60. All other is also possible, but the most intense formation happened for carbon-60. Now the question is, what is the structure of carbon-60? So this is again consisting of carbon alone. So you can think of it as a allotrope of carbon, which consists of 12 pentagonal and 20 hexagonal faces symmetrically arranged to form a molecular bond. So it was given a structure as that of a football. So if you check the earlier previous football structure, you can see that it consists of 60 points or corner points. Okay, so the people thought that, oh, it is nice to think the closed structure. Already we have confirmed or concluded that carbon 60 should have a closed structure. So the people gave the molecular bond structure to the carbon 60, which consists of, here you can see, it has a hexagonal as well as pentagonal faces to form a closed structure or to accommodate the 60 carbon atoms. So how many pentagonal faces? 12 pentagonal faces and 20 hexagonal faces are present in the molecular bond. So it was actually based on the structure given by an architect, Buckminster. So he has he was an architect who devised a stadium like this, which consists only of this kind of structure, and hence it is called Buckminster Fullerene. So the shape was given by Buckminster and hence the name Buckminster Fullerene. And what is another speciality of carbon 60 is that the carbon 60, it's like a ball. You can suppose like a ball. So such a carbon 60 molecular ball will bond with other carbon 60 to form a crystal lattice. Okay, so what is a crystal lattice formed by the carbon 60? The crystal formed by carbon 60 is an FCC lattice. So what is an FCC lattice? It will form a cube, okay, where each point is occupied by 60 carbon. 60 carbon atoms are occupying a single lattice point. Okay, and it has a FCC lattice. FCC lattice means face-centered lattice. Face-centered lattice means the molecular ball will be present in the corners as well as on the centers of each face. That is what you mean by face-centered lattice. So the crystal formed by carbon 60 is that of a FCC structure, and each carbon 60 molecule will be separated by a distance of 1 nanometer. And they are actually, there are no bond formation, no bond is there between two carbon 60 molecule. They are held together by van der Waals force, and as such it is an insulator, and they are soluble in benzene. Okay, so we'll see about more details in our next class. Thank you.